Hi everyone, in today's video we'll learn about inverse and composition of function. Okay, so what is inverse of a function? Inverse means actually when we define a function, when we write a function which we actually write like this. F is a function from a set A to B. So when we say inverse, we means there exists another function G which maps from B to B, comprising all the elements from B. That is, for example, suppose A takes 1, 2, 3. Suppose F takes 1, 2, 3, 2, 2, 4, 6. That is 1 to 2, 2 to 4, and 3 to 6. Then inverse function G. So this is F. Then G pulls back 6 to 3, 4 to 2, and 2 to 1. That is G, or the domain and range will interchange with each other. Okay. So when we say function f from A to B has an inverse, if and only if the set obtained by reversing the order pair of f is a function from B to A. So if we reverse that order, that is the order pair AB, if we can write BA, set of all BA, so that for all AB are in F, then that is set is called as the inverse of the function f. For example, suppose we have a function f from A set to B, okay, comprising elements 1, 2, 3, 4 and x, y, z, t. That is 1 map with x, 2 map with y, 3 map with z. No. Then f inverse will be written. So here for AB, here we get BA. So the order of the ordered pair is in order. Okay. So for 1x, here we get x1. For 2y, here we get y2. And if we here we will note that if I inverse the inverse, then f is from A to B. F inverse is from B to A. Then if I find inverse of inverse, then inverse of this will be A to B, which is the order pair AB. Okay, which is same as the okay. So inverse of inverse is the same function. In say now we have a proposition that if and the necessary condition of the a function to have an inverse is that it must be 1 on and 1 to. So if it is 1 many or not onto, what will be the problem? Suppose I have two functions. I have a function 1, 2, 3, 4 x, y, z, and t. Suppose 1 maps with x, 2 maps with y, and 3 maps with z, and 4 also maps with z. Okay. So this function is clearly not 1, 1. It's clearly 1, 1, but not onto. Okay. As this codomain is not equals to the range, because here is the function doesn't map with t. So when I found inverse of this function, this t will be left out. Okay, so this cannot be a function, because the definition of function is that every element of the domain set should participate in that function. Okay, so this t must participate in the function if we constitute a function f inverse from B to A. But here we see that there is no image of t in A. So this cannot be a function. So the necessary and sufficient condition of a function to have inverse is that it must 1 and 1 2. Next, for example, here we have two examples. That suppose we are defining a function fx from real number to real number by 2x minus 3. Okay, so it is clearly 1 and 1 2 because for every real number I get a real number here. Okay, so the inverse of this will be actually find inverse. Okay, so by this technique. Okay, so we assume fx to be y, fx to be y, but we have fx as 2x minus 3. So this is y, and solving this x will be 1 by 2 y plus 3. So since the function, suppose I have function x and obtain a result in y, and this it is in a, it is in b. Okay, so when I found inverse, okay, that is here f inverse of x, sorry, f inverse of y means x. Okay, f inverse of y means x. So because it is f inverse function takes this y and find a value as x, so this x will be f inverse of y, and the image will be like 1 by 2 of, and this value will be in this part. So we write 1 by 2 x plus 3. In this way, actually find the inverse of the function. Actually alter the both sides by altering the both sides. Similarly, here we have another example that a function is defined from a to b. Okay, here the b is the positive real number including 0, and a is the negative real number including 0. So f is defined from negative to positive. So the range of function f should be always positive. But when we found f inverse, that function is from b to a, so this range of the inverse should be negative. Here the function is defined as fx is equal to x squared. So in above, like x and y, a and b, let's assume this fx as y. Okay, y equals to x squared. Then x will be root over y, and we know this root over y square root and 2 plus and minus. So this x, we write this x as f inverse y, and we replace y. We actually alter this x and y. So replace this by root over x. What we have to write here? Plus or minus? Since the image f inverse y will be a, so this and a, all elements are negative, so we have to write negative here. Okay. This is the inverse of this. So this is all about inverse of a function. Now we know about composition of function. Okay. So composition means what? Composition means actually addition type. No, not addition. So let's understand with this example. Okay. So when I say f is a function, when I say f is a function from a to b, suppose f is a function from a to b, and g is a function from b to c, then composition is like transitive of function, transitive property of function. Composition is another function that maps from a to c. Okay, a to c. That is for a, B and C two function. We have F A to B and B to C. This is G. But the composition made from A to C H. Okay, so it is just like the definition. That is F from A to B, G from B to C are function. Then the composition of G and F is another function, and this is the representation function. Okay, composition. It is defined by G of F of A is G of F of A. It actually has to be write like this for all A. Okay, so for example. Suppose we have A set as A, B, C, B set as X, Y, and C set as U, V, W. Then F from A to B is like that, AX, BY, CZ, and G from B to C is like XC, Y, W. Then G of F of A, because this composition is from A to C, it takes all element of A and find all element of, find the image in C. So we take an element A. Okay. So G of F of A, that will like this. Okay. But F of A has image X. So this F of A will be X. So G of X will be, and then G of X will become C of X, and image of X will be E. So G of X will be E. Similarly, for the case B, G of F of B, which equals to F of B, image of B is Y, and G of Y will be W. So for A we have image U, for B we have image W, for C we have image U. So AU, BW, C. So this is the composition of two functions. Now we found the composition of algebraic function. For example, suppose we have given fx as 2x plus 3, okay, and gx as x square plus, then the composition of g of f will be g of f of x, and that this f of x will be 2x minus 3. So actually we use in g of x 2x minus 3 in place of x square. Okay. So this becomes this. So this is the composition of g of f. We found f composition G, that means f of g of x, and we use this g of x square plus 1 in place of x in f of x. Okay, so 2 into x square plus 1 minus 3. This is the composition of function. Okay, so this is all about composition and inverse of a function. So if anyone has any doubt or query, please comment. Okay, and if you enjoy the video, like this video and subscribe to this channel. Thank you.